What's up, sixth graders? You are about to start Lesson 5. And Lesson 5 is wrapping up our unit on ratios, but what we're going to be doing now is we're going to be talking about how ratios and percents are related. So this is all about percents. So here's what you're going to be doing. First of all, you should be on page 38 in your math book, and you should have a calculator. If you don't have that ready, pause the video to get it ready. Second, remember the rules here. I'm going to be giving you certain directions to try something with the video paused and restart it. Please follow those directions and you'll learn the most from it as you can. Third, if you're not sure, you give it your best shot. If you're wrong, so what? You learn from it. That's how you learn in math. So remember that. Don't get stressed if there's something you're not sure of. So anyway, this is an introduction lesson to solving problems with percents. So on this first page on 38, we're going to take what you already know about ratios and we're going to kind of guide you to something with percents on the next page. So here is your first job. You are going to start by reading the problem at the top with me. We'll underline some stuff and get started. So it says, on the first math test, Kaiko answered 19 out of 25 questions correctly. So I'm going to kind of circle that for the first math test. Okay. On the second math test, she got 17 out of 20 correct. On which test did she get a better grade? So we're going to have to answer that question comparing test 1 to test 2. Now, here is your job. Your job is going to be to pause the video and to do A through F completely on your own. When you are done, I want you to restart the video and then I'll go over the answers. And you could fix any mistakes that you may have made. All right. Work on A through F only. Do not go to page 39 yet. Restart the video when you're done. Go. Okay, so let's see how you did. You should have A through F completely done here, and we're going to start. So A says, write a ratio and fraction form to compare the number correct to the total questions for each test. So for test 1, Kaiko got 19 out of 25 correct. So that's just 19 out of 25 written like a fraction. On test 2, Kaiko got 17 out of 20 correct. So that's your answer for A. Remember, if you make a mistake, pause the video, fix it. Just learn from it. Think about the mistake you made before you restart the video. Now, B says, can you compare these two ratios as they are written? Explain why or why not. Now, technically, you can as they're written if you understand that, but what I'm going to say is, I'll explain it in words first and then I'll write it down, is no, it's difficult to compare them. When you're looking at this, like, yeah, she got 19 right, but there were 25 questions. Yeah, she got 17 right, but there are only 20 questions. So it's hard to compare fractions if the bottom number, the denominator, is different. So that's what I'm going to write here. I'm going to say, no, it is difficult to compare fractions with different denominators. Now, if you said yes, you can compare them because maybe you're pretty good with this stuff and you know ways to compare the fractions and you explain it, that's fine. You don't have to change it. But I'm just going with when the denominators are different, it's kind of tough to compare fractions. All right. So if you want to make any changes, you could pause the video. Now, C says, look at the table. How are 50, 75, and 100 related to 25? So remember, this is going back to the 25 questions on test 1, right? So when I look at the table, notice this was the ratio that Kaiko had correct on test 1. She had 19 correct out of 25 total questions. So it's asking how are 50, 75, and 100 related to 25. So I'm just going to answer that. I'm going to say, if you count by 25, you will hit 50, 75, and 100. Okay, did you notice that? You count by 25, 25, 50, 75, 100. That's all I'm saying in my own words. You may have something different, and you may not have to change your answer. Now, by the way, there's a math, there's a math word for this when these are called counting by 25 numbers. So the math word is called multiples. So all of those numbers are multiples of 25. Now the second part of C says, what do you need to do to complete the table? Now complete the table. So what I'm going to do here is to complete the table is, since the bottom numbers are counting by 25, that means the top numbers need to count by 19s. All right, so I'm going to do that. So 19 plus 19 is 38. 38 plus 19 is 57. 57 plus 19 is 76. So let me write my answer over here. I'm going to say you need to count by 19s. Or you could say list multiples of 19s. All right, now D is going to be looking at the second table. How are 40, 60, 80, and 100 related to 20? Now remember going back up to Kaiko's second test? Kaiko had 17 out of 20 on test 2, right? So we're talking about that 20 denominator down here. So notice down here, all of these numbers are counting by 20 numbers. Now this time I'm going to use the word multiples because I already talked about that. So I'm going to say, they are all multiples of 20. Now, I don't expect you to have used the word multiples in your answer to this, but if you did, that's awesome. But what I would like you to do is just write down in parentheses, write down the word multiples, just so you start learning that that's what we call those words. All right? So they are all multiples of 20. Now, E says, oh wait, I'm sorry, let me finish it here. Use this information to complete a table of equivalent ratios for the second test. Now remember here, as we counted multiples of 20 to get the bottom number, right? So now we need to count multiples of 17 to get the top numbers. So we have 17, 34, plus 17 is 51. Plus 17 is 64. Plus 17 is 81. I think. Did I mess that up? Yeah, it should be good. Oh, no, sorry, guys. I screwed that up. So I screwed up the last two. So 51 plus 17 is 68, not 64. Plus 17 is 85, not 81. So sorry about that. All right, now, E says, look at the two tables. Which ratios can you use to compare the test results? Why? Now, this is kind of what we're guiding you to, because remember, the original ratios, and I'm going to circle them in orange here. Test 1, she got 19 out of 25. Test 2, she got 17 out of 20. And it was difficult to tell what she did better on. But when we look at the two tables, there are two ratios that have something in common. So did you notice that the last ratio in each, they are both out of 100? So these are the ratios, because they have the same denominator, that we can use to compare how she did on the test. All right, so we're going to say the ratios out of 100 can compare her results. We'll just say the ratios out of 100 because they have the same denominator. Okay, so that's what we're trying to get you at here, is if we can get those fractions to the same denominator, it makes it easier to compare. Now, the other thing is, what we're going to learn, since we're talking about percents in this chapter, is when the denominator is out of 100, it's kind of like our key to everything. It's going to make things a lot easier, and you're going to see that with percents. Now, F said, on which test did Kaiko get a better grade? explain. So she got a better grade on test 2. Now the reason is because they were both out of 100 by this point, right? So 85 out of 100 is higher than 76 out of 100. So that's all I'm going to say. I'm going to say 85 out of 100 is better than 76 out of 100. Okay. So you should have an answer similar to that, even if your words are slightly different. All right, so if you need to, you could pause the video and fix any answers that you had wrong. But you might have had some right if you just had different words than me. But anyway, we are moving on to page 39. So on page 39, we're going to do some reading in the Find Out More section on top. And then we're going to go down and have you do the reflection. So for this, don't zone out on me. I know it can get boring, but I want you to just pay attention. So it says, the ratios on the previous page, 76 out of 100 and 85 out of 100, can be expressed as fractions, decimals, and percents. A percent is a rate for every 100 or per 100. The symbol, that percent symbol right there, signifies percent. Base 10 models can be used to represent fractions, decimals, and percents. So let's show you this. In this first model here, there are 76 shaded out of 100 total. And that can be written as the fraction, 76 out of 100, as a decimal, 76 hundredths, and as the percent, 76%. These are all equivalent. Now, the one on the right, we have 85 are shaded out of 100. And 85 out of 100 can be written as a fraction, as the decimal, 85 hundredths, and as the percent, 85%. So these are also all equivalent. Now down below here, it says, here are some fractions, decimals, and percents that you will see and use often. So in other words, let me tell you about this table. These are fractions, decimals, and percents that are equivalent that you, as a 6th grader, should just know and have memorized. And you shouldn't have to do any math to figure them out. So, for example, you should know that 1 out of 100 is 1/100th is 1%. You should know that 1 out of 10 is the same as 1/10 or 10 hundredths and 10%. You should know that 1 out of 4 or 25 out of 100 is 25 hundredths is 25%. You should know that half or 50 out of 100 is 0.5 or 0.50 is 50%. You should know that 75 out of 100 or 3/4 is 75 hundredths is 75%. And last, you should know that 1 out of 1 or 100 out of 100 is a whole, which is 1.00 or just 1, and that's 100%. These are fractions, decimal, percents that you should know. So now, we'll read this last point before you reflect. Sometimes it is easier to use an equivalent fraction when given a decimal or a percent. So here's what they mean. Imagine you didn't have a calculator for a second. They're saying if you had to figure out 25 hundredths times 80, that's kind of a pain in the butt to do multiplication on paper with. Now, if you have a calculator, it's not hard. So they're saying it's easier to figure that out as a fraction. So instead of 25% times 80, think of the equivalent fraction, 1/4 times 80, which is the same as 1/4 of 80, which means to find 1/4 of 80, you just do 80 divided by 4, which is 20. So all they're saying is sometimes fractions are easier than decimals when you have to compute. Okay? Now last, here's your reflection question. It says, why do you think percents are used to compare ratios when the wholes are different? So I want you to think back of Keichel's test. In the first test, she had, I forget her grades. It was 19 out of 25. Okay. She had 19 out of 25. And the second one, she had 17 out of 20, right? We didn't compare those fractions. So this wants to know, why do you think percents are used to compare ratios when the wholes are different? So remember, we figured this one out to be 76%. We figured this one out to be 85%. So why do we use percents to compare ratios when the wholes, the 25 and the 20, are different numbers? That's what they want to know. So pause the video, and I want you to just take a second to write 2, maybe 3 sentences at most, answering that question. Okay, pause the video, write your answer now. Go. Okay, so you should have your reflection written for number 1. So I'm going to write my answer here. Yours does not have to be the same. Remember, this is a why do you think question. There's no right or wrong answer. So I'm going to write down what I think. I'm going to say, because comparing fractions with different wholes is difficult. I'm not done yet. Is difficult, comma. It is easier to understand the percent because it is only one number. Okay, and all I mean is, like with these, you have to be like, okay, there's 19, but it's out of 25. There's 17, but it's out of 20. There's a lot of numbers you have to deal with in your brain to understand them. But when it's percents, you are only comparing one number because they're both out of 100, remember? So you're only looking at the 76 versus the 85. So that's why I think it's easier to use percents when comparing ratios with different wholes. But you may have said something different. Anyway, guess what? You're done with me. So you're done with the video. Thanks for watching, as always.